So, good afternoon. I'd like to welcome folks to the June 2025 Indicators of Behavior Project meeting. I'm the chair and host, Charlie Frick from Johns Hopkins Applied Physics Lab. And today we might have a little bit of a shorter agenda, but would like to give a little bit of news from the project as well as share some information from the workshop that we held this past May at the Cyber Threat Alliance TIPS conference. And then there were a couple open items for discussion that I'll be following up on the listserv and the Slack channel when I give out the notes and minutes from the meeting, because I'd like to gauge people's interest in a couple additional efforts that we might like to take with indicators of behavior, as we've gotten some feedback from folks for some additional capabilities. But with that said, I'll just let you guys know general updates. We are actively working our latest revision of the standard APT 37 Reaper reference implementation. There's been a little bit of community feedback on how we provide the STIX extensions. We do plan to still include extension objects inside the reference implementation bundle, because part of the point of a reference implementation is that folks can download it and have access to everything. But we've also gotten feedback that some folks would like to see that data provided similarly to how the STIX technical committee provides the common object repository. So that would be more of a directory with the schema provided with their UUID as the name of the file. So we plan in revision 4 to still include the objects inside the bundle itself, but we'll also provide that directory of extension schema for those that are interested in it. And as always, we maintain these extensions through the STIX extensions repository from the Open Cybersecurity Alliance. But along with that, we are working to take a what we're calling a Living Off the Land bundle that was based loosely on the Volt Typhoon campaign. And we did a small preview of that at the CASP Plug Fest back in April. And we are actively adding some more detail to that, so that also will be an example that we'll make available on the GitHub for the IOB project. Aside from all that, we are also actively in the throes of our operational pilot with Hudson Alpha Institute for Biotechnology. And we are refining detection and correlation workflows that we'll be putting into production down there. That's going to be looking at a few different attacks that are designed to highlight response to theft or data integrity attacks for genetic data. So as we get those put together, we'll be gladly putting out some public papers showing the insights that we've gained from those pilots. With all that said, I'm going to pivot for a moment now and kind of go into our technical talk. Back in May, the Cyber Threat Alliance graciously gave Indicators of Behavior an opportunity to speak at the conference, but also host a joint workshop on IOBs, along with the Center for Threat Informed Defense giving a talk and workshop on attack flow. For those not familiar, attack flow is a graphical user interface that can map out the threat timelines while using aspects of the attack framework to provide that a consistent visual aspect for how you can make a human readable narrative of the threat. And we were having a workshop on how one can use both IOB and attack flow in order to represent adversary behavior for the human analyst as well as for the machine. And what I wanted to do today was just share a few highlights from that workshop. The first thing I'll put in the chat, but also I will share in the minutes for the meeting. All the workshop materials for how to create indicators of behavior, we do have available live right now for free on our GitHub. So I have the link to that inside the chat for this meeting, and we'll share it in our meeting minutes. But I thought it might be good today just to take you guys through some of the materials that we have available. And then I'd like to pivot for a couple items of discussion and open up for general discussion. And then if we're done a little bit early, we'll wrap up and adjourn. So allow me to share my screen, and I'm just getting my Zoom windows in case there's any any questions that pop up. So your patience is appreciated as I'm just getting the chat on my screen so I can see if anybody has questions. But what we wanted to do with this workshop was we've talked a lot about the structure for indicators of behavior, showing the STIX extensions, laying out our plans for how we integrate with different tools and support things like Threat Hunt. One of the challenges that people still face is making these bundles of STIX objects. So we put together this small workshop to take folks through the process of how a threat intel analyst would be able to read threat intelligence and turn that into an indicator of behavior bundle. Towards that effort, we made a fake threat bulletin. So for those of you that might have been here in our December meeting, we had done an example that we called Spark Rainstorm. And so we took that example and then fleshed that out a little bit and built this artificial threat bulletin. This is available in that GitHub link that I just sent. But it's a simple little case of an adversary doing some basic living off the land techniques. In this case, we have an attacker that got malware execution on a target, then established persistence and C2, but then utilized PowerShell PowerView commands to enumerate a network, conducted lateral movement, and then stole the ntds.dit file from an Active Directory server so they could crack credentials and embed themselves deeper in the network. And so the report takes you through that threat narrative, provides MITRE attack information, as well as a few more bits of information and some fake indicators of compromise. And all over this report, I've tried to stamp as many disclaimers as possible that this is all made up. But we did all this so that perhaps not just for IOB, but for other use cases, if folks needed an artificial cyber threat intelligence report, this is a resource that you're free to download and use as you wish. And so with that, we took our workshop attendees through a small exercise on how to build an indicator of behavior bundle. And I'll take you guys through a couple of those steps right now. Again, this is all, that link will be shared out, will also get you to a page where you can download this presentation, plus all the workshop materials for building an indicator of behavior bundle. Given this is the IOB subproject meeting, I'm not going to do as much of the background and what IOBs are, because I think most of us are familiar with them. But as I was bringing in a new crowd of folks that may be less familiar, we had a little chat about some of the differences between traditional indicators of compromise and indicators of behavior. Mostly that we're looking more at sharing detections that are primarily meant for automation that could have higher false alarms, but be correlated to detect more repeatable adversary behaviors in a way that's a little bit more proactive than hunting for indicators of compromise. And that we've been utilizing several easily machine ingestible formats such as STIX and Sigma and Cacao so that we could use automation. One's not forced to, but we like to make sure that we set up a process that makes it very easy to ingest and tailor these things for your own environment by taking advantage of open standards. So, and for those familiar, we do maintain some scripts to graph this type of information up, as well as been working with CTA and others on tools to also help an analyst build STIX bundles. But I thought it might be good today, just for our technical portion, to talk a little bit about the process of how we go about identifying and extracting indicators of behavior and building those detections and correlations. So I mentioned we have the Spark Rainstorm threat report that I shared with the class at the workshop. And it includes tactics such as staging an interpreter payload from Metasploit, using PowerView for reconnaissance, and using the native NTDS util on Windows in order to access and steal credentials. So what we did is look at those attack patterns, and I want to take you through how we normally go through identifying behaviors when we're doing when we're building a new IOB bundle. So what we normally do is we start by looking at the threat narrative in terms of those attack patterns and the sequence that they're occurring. Now, as this was originally done as a joint workshop with AttackFlow, this was a very good chance to hand over to our good friends at CTID a way to demonstrate AttackFlow, being a GUI to show that narrative timeline in a visual format that utilized MITRE ATT&CK. But for this example, I'm going to do a simple case focusing on patterns that would leave observable traces for a defender. So for example, in the Spark Rainstorm narrative, the attacker, after they stole credentials, put them through a password cracker. That would be an accurate piece of intel, but password cracking by itself, not super useful for threat detection because it's not going to happen on your network. It's going to happen offline. So instead, we just decided to pick these three attack patterns of the uploading of malware, the execution of PowerShell with the PowerView payload to enumerate a network, and the theft of the NTDS database from the password store. From there, there's a different way to think about this. We really want to think about what the adversary wants to achieve, not the exact way that they're going to implement this attack pattern. But think about what their goal is, because that's going to help us think about what's going to be observable patterns on the machines and networks that we're monitoring to see that goal. And so for the moment, let's not worry about false positives, but let's just think about type of behavior. So they uploaded malware, and there are a million ways to hunt for file hashes and specific types of malware. But what really happened was a user got spearphished and they executed some malware. So they were from a somewhat abnormal place. So in this case, let's say we have an endpoint system that's executing binary code from an unexpected location. Most of the time, Windows is going to have those files launched from System32 or the apps directory. And maybe we might want to look at an analytic to know for some automation to say, hey, let me know any computers that are executing binaries directly from user space, like their home directory, or that are being spawned from the mail client. I might want to know about those. Also, the attacker used PowerView. And if I am doing now we can read that it's good to do log and monitor PowerShell logs. There's a whole lot of PowerShell logs, but we might want to look for certain PowerShell entries that are specific to the use of tools like PowerSploit and PowerView. So that might be a behavior that could be more observable if we're logging that type of data off our endpoints. This also I'm taking the idea of sending this data to a SIEM. Obviously, this could also be done in an EDR or any number of ways. And then finally, for the theft from password stores, there are a lot of ways that password stores get compromised. But in that threat narrative that we shared, they were making a copy of the ntds.dit database on an Active Directory server. And that's something that could be observed too for when that database gets copied. So we want to think more along the lines of what they're trying to do. The adversary is trying to get new code executed when they want a payload to fire on a victim. If they're going to use tools like PowerView, they're going to use crafted commandlets for sending LDAP requests to map out a network. And so we want to see what's going to be a repeatable observation for that, as well as they might copy the database from the domain controller. And so that one example is where I'm going to pivot to show you how we would go build a detection. Now, one of the challenges that I see I've gotten a lot from folks is, well, we have MITRE ATT&CK, just do the detections that ATT&CK says. And ATT&CK does give very accurate guidance on what type of detection to build, but by the very nature of it being focused on tactics and techniques, it often is not specific enough for you to have a detection you can go run in your SIEM or on your EDR without you having quite a bit of nuanced knowledge. So from Spark Rainstorm, I show you an attack pattern of stealing credentials from the NTDS database. And if I look that up in ATT&CK, that's going to be attack T1555, which I highlighted in red on the attack matrix there. And if I start just looking for analytics against T1555, well, I can get a whole lot of options that I might need to tailor and look through. And that could be pretty challenging for a lot of teams. Additionally, a lot of those analytics are very good analytics, but they're very much tailored to how one instance of this attack pattern was seen in the wild. And so you can look at an analytic like the one there. I'm not making fun of it. I'm just saying that's a very specific analytic that also is not going to capture someone stealing the NTDS database, but it is an example of an accurate analytic against T1555. It's the whole challenge of having a many-to-one relationship, which is going to happen with taxonomies. So we need a different way to think about how we're going to detect that behavior. So let's think a little bit more how we can take advantage of having a kind of more behavioral mindset. Instead of looking at exactly how Spark Rainstorm folks did what they did. In their case, they used the NTDS util command. But let's not worry about how they did that. What are they doing? They're trying to steal a database file. And so if we can detect that database file being copied somewhere else, they're going to have a completely different approach if we could find anytime that database is copied. Because the only way for them, if we can detect that database being copied, then the only way for them not to trigger the detection would be to not copy the database. I don't care about what command they ran. I don't care what binary or buffer overflow they used. I care about whether or not that database got copied. And the good news is there actually is a built-in log for Active Directory to event 325 under ESENT or ESENT or ESENT that tells you whenever that database is copied anywhere. That could be, there could be false positives. We might be doing backups. But we do have a log that says that database was copied. And we know that database holds password hashes for all the users on our Active Directory. So maybe we want to have an analytic that looks for any time that database is copied. And that would be a pretty easy one for whenever event code 325 fires. Now, there could be lots of false positives. Maybe you have legitimate processes that make copies of that database as part of your backup, or maybe there's other activities and tools that are accessing it. But again, this is a very repeatable detection. It might be a little loud sometimes. That's why we're going to work on correlation next. But focus on the what, not the how. Because otherwise, we're constantly refining our analytics for every new little trick that the attacker tries. Instead, let's just look for finding the result of them being successful and use that to clue us in, so that the only way they can't trigger this is to not achieve this particular result. And so that's where we normally want to take those detections, and what we've done in a lot of our examples is build these out into Sigma format. Stick shifter is also a viable route here, but we want to be able to show something that is a little bit, vendor agnostic that could be read into many different platforms. And so this is one way we could represent saying, hey, go look for event 325, and we might, that's an analytic that we're going to want. But by itself, it's probably not sufficient. And that's why with IOB bundles, we include multiple detections and correlation logic. And so I'm doing a simple example here of saying, let's take two of the behaviors from the chain in that report. The attacker uses PowerView. Well, there is another Windows event that will notice whenever that can log the contents of any script block being loaded onto a system. PowerSploit normally is not part of your standard deployment in an enterprise PowerShell environment. So if you want those commandlets from PowerSploit as an attacker, you're going to import those modules onto your victim. And if you're streaming the logs off your machines in your enterprise, there is a PowerShell log. I think it's 4104, but please don't quote me 100% on that. But that will capture the text of whatever scripts were uploaded into that PowerShell session. And you could look for some of the specific PowerView commands like get domain computer, and you could capture a bunch of fields from that log. But here we might just say, for argument's sake, I want the user ID and the timestamp. Similarly, on the NTDS event code 325, there's multiple fields in there, but maybe I want the user ID that executed the command and the time that it happened. And then we'd have some correlation logic saying like, hey, did these two events occur executed by the same user account within 5 minutes of each other? And if they did, we would give them points for each one of these that were identified in the case. And this is something automation has running in the background and saying, hey, okay, I saw PowerView, I saw the NTDS database, they were done by the same guy. Add these together, that's 3 points. And a simple logic, like if I have more than 2 points, let's now notify an operator. Now, in practice, this would be a little bit more complex logic. And so that's why we also have a full, in this case, BPMN workflow for how we combine those scores and analyze them. And that's also inside the bundle from the workshop, as well as a standalone file. But we can share that logic, and then that can be translated to automation in order to improve our detections. Because I'm not trying to really build a Spark rainstorm bundle. What I'm trying to do is share detection analytics and correlation workflows for malware loaded onto machines, followed by network enumeration with PowerShell, followed by credential theft. I want to try to find that series of activity because I can imagine a large swath of attacks that would use those elements. And ideally, if I have this in place and well-tuned, I can then be more proactive if other actors tend to mimic or reuse some of those techniques in the wild. And that is where we get some of the more power from doing the indicator behavior approach, but thought it was good to share at least some of the logic that we use for how we design this out. Now, this example in the workshop, I used BPMN, but Cacao and Cacao Roaster are also viable candidates. And I mentioned that out because we're going to talk a little bit more about Cacao in a moment. But this was what we shared for the event, and then utilize the STIX modeler in order to put these together into a nice 2.1 compliant STIX bundle and have that available for folks to share. And if you do visit the link that I'll be putting in the notes, you'll have all the workshop materials where you'll have the PowerPoint slides as a PDF, that threat bulletin. This Spark Rainstorm JSON is an IOB bundle with all the information from the workshop, as well as the STIX extensions that were used for building that bundle, the detection and correlation information, and even the icons that we loaded up for the IOB elements for the STIX modeler. And so all that's available for you on the GitHub as well. I'm going to stop sharing my screen for the moment and ask if there are any questions from that little demo from the workshop. Just give a hard minute and see if someone was wondering anything. Okay. So that now brings me up to a couple new items of discussion for the group. There have been two new elements brought up for areas that IOB could collaborate. One of these is at Brett Jordan this week brought up the idea of IOB playing a larger role with Cacao version 3. For those not familiar, Cacao is an open standard for security playbooks, and they're currently working heavily on version 3 of that specification. And they're interested in better understanding how to use Cacao to do some of the IOB correlation and response workflows. This is something that we have a lot of interest here at APL, but I also wanted to ask the folks here in attendance, but I'll also be sending up follow-up discussions on Slack and Listserv to see who else might be interested in some collaborations with the Cacao team, because we're seeing some desired features in version 3, particularly with variables and how they're passed between steps in a workflow that we'd like to flesh out better, because we're finding that's some pretty needed functionality if we want to be able to execute some of these security playbooks. So no need to stand up in the middle of the call right now, but if you do have some thoughts on that, I'm going to stop talking for a second and give folks a chance to respond if you have any thoughts about the ideas of using IOB with Cacao that you'd like to make sure we focus on as we reach out to Brett and Vasilios. Excellent. Well, as we do some of that collaboration, we will gladly share some of the feedback with everyone. I also had another topic that was brought up to us by some community members that we're actively looking at here at the lab. There was some discussion on what we might want to do if we're going to use IOB as the container for malware behavioral analysis. And we're actively looking at some ways to look at various malware analysis reports and help capture the attack patterns, and ideally maybe use some machine learning and maybe some large language models like the Cisco Foundation SEC model to see if we can start designing out a more repeatable way to classify emergent or repeated behaviors from from an area that's been seen before. Because we think that that could be a really valuable way to generate a lot of behaviors and then potentially start hosting a repository of known and seen behaviors for others to be able to take advantage of. And so I wanted to make that announcement that that's an area that we're looking into, and also invite anybody from the call, the Slack, or the listserv, or anywhere else that's interested in participating on some of that to reach out to me so that we can set up a splinter group, if you will, to better find best practices for taking manual and automated malware analysis and packaging it up into sticks. And oh, Linda, I just saw your comment in there, and very glad to have CTA's involvement. So as I schedule anything with either of those groups, I'll be sure to have you invited in there, as some might be some brainstorming sessions, as well as trying to get a few things off the ground to go execute and build some examples. But any other thoughts or comments from anybody on those ideas for Cacao or malware behavioral analysis? All righty. Well, then oh, sorry, Patrick, you came on camera. Is there anything I can do for you, sir?
Oh, good afternoon, everybody. Or evening, morning. Just gonna, wave the flag here that, hey, let's bring this to Interoperability Village. So whatever we can do to help facilitate testing and demonstration of this, any of these. So, I'm on the hook to do the new architecture and get something out by this Thursday. It's going to be a challenge, but I'm going to try. So just look for the notice, folks, and anxious to have you all join the build some huts in the village. It's going to be fun.
And will you be going over that? The CASP call, is it 1100 on Thursday?
Yeah, that's what I'm due to. Yes.
Okay. I just wanted to get the right plug for the
Yeah.
right
And
time.
it's already Tuesday, isn't it? Okay.
Yes.
We're
But
fine.
11 a.m. this Thursday, the cybersecurity automation subproject slash interoperability village slash, I keep using the wrong names because we've changed them a lot over the years, but we'll be having another call. And Patrick's been working very hard to help us bring to life a environment where we can start integrating multiple tools so that we're not waiting to all sit in a room at one office building one or two times a year and try this stuff. We can actually start being more deliberate. And I think it could be a very good environment for both the cacao analysis and the malware behavior analysis. I just want
Thanks,
to
sir.
I just want to have some
Yeah. So
ground rules
yeah,
before I
one of
bring
the
live
keys. Yeah,
malware.
I appreciate. So one of the key things is that somebody pointed. Anyway, we have a new architecture using HeadScale, which is the open source free version of Tailscale. So instead of Mesh Central, which is going to be the mesh framework, we're going with this new model, which actually gives us a lot of flexibility because it is a mesh network. So in any case, so the whole architecture got changed. So I need to get caught up and get the processes. I also need to make sure it works well. So anyway, coming
Cool.
soon to a meeting near you.
Looking forward to it.
Thank you, sir.
Thank you, sir. Are there
And
any
and if
other?
and if you haven't joined the interoperability working group, please do.
Yes. And I will give a plug for that with better words when I write up the meeting minutes. But absolutely, the Interoperability Village is one of the premier events for the OCA where we're able to actually start showing rapidly the value of all these open standards and interfaces. And I think it's a very, very worthwhile effort. I wanted to take a moment and have an open floor for comment. If anybody had any questions on the project, where we're going, what's next, I'm taking time to answer your questions. So I'll pause for a moment and see if anybody has some. Very well. In that case, I will, get ready to wrap things up, but I'll have the meeting minutes and the recording out as soon as possible. And I thank everybody for taking their time today. With that, I'm going to stop the recorder